Let me introduce myself very quick. Wolfgang Alper from Intelligent GmbH, certified trainer, been with Zabbix for, I don't know, 15 years plus. And today I would like to share with you the presentation which is called Zabbix in the Subway, Next Station Zabbix. And let me try this one here. Here it works. So before starting, I would like to say thank you to the Münchner Verkehrsgesellschaft MBH, to the Stadtwerke Munich GmbH, and to Mr. Sandro Gelha. They gave the permission to do this talk here on the conference in Riga and provided some of the material. So thank you. And let's go ahead. First slide. So what you see here is a tram. Anyone has seen a tram before? Okay, so that's fine. Yeah, it's a tram in Munich, and I like trams. Thus, I have another slide, and what you see here is again a tram, a little bit closer than the first one. Yeah, everyone uses them to go to work, to go back home. In Munich, we have a little bit more. It's not only trams. We also have something in the underground, and those that have been in Munich before know this is a subway in Munich. It's the older model. It's the Model A2. Yeah. Anyone been in Munich? Wow, so many people. Great. Yeah. They showed me the new model, which is a C2 model in Munich, and this is the updated one. And now you might ask yourself, why is Wolfgang showing us trams and subways here on the Zabbix conference? What is the relation to Zabbix? But I'm pretty sure that you already guessed it, at least at least when I show you the following slide, which is this one. And what you see here is a map of subways. It's a Zabbix 3.2 map, by the way. So you see a map of subways, and you see that some of those subways have an issue. And the next one shows you a map of trams in Zabbix. And what is the missing part is the map of stations in Zabbix, you know, where you get the information when the next tram is going to arrive. So this talk really is about monitoring trams and subways in the heart of Munich with Zabbix. So when a new tram or a new subway goes into service, some equipment needs to be added to those vehicles, and I list a few of them, like video cameras, like a network video recorder, a storage system, and depending on whether we are using a tram or subway, we need some connectivity, and we also need connectivity across all of those vehicles, so the wagons need to talk to each other. So there are some components added, and to give you a better idea about how those components look like, this schematic shows, for example, on the bottom right, you see here the NVR, the network video recorder, or on the top you see the network attached storage, the MSCU, etc. So, and of course the cameras. And let's talk a little bit about how this stuff is being implemented in Zabbix. And basically each device inside a tram or subway is treated as a host and is monitored for availability depending on the type of device. And each tram and subway itself is managed as a host group. Now, if you have a subway line or a tram line, like for example U-Bahn number 9 or S-Bahn number 104, then you have, of course, more than one tram or more subway, and these are organized in subway lines, and those do match nested host groups inside Zabbix. So we're using the Zabbix 3 host group nesting feature. And of course, any device that's being monitored depends on the connectivity of the MRCU or the LG router. And on top of that, and that was a design decision done by Mr. Sandro Gelha. The idea was really to give as much visual feedback from Zabbix as possible. So for any host group, there's a map created, and you remember the host group reflects to a tram. And we also have for the entire tram line maps. And these maps are automatically created like for each tram, and we then have sub-maps that allows us to look inside of this tram. And here you see the same nice slide I like very much, as we saw before. And if I click on one of these host groups here, of those trams in this case, then I get a special map specific to that tram. And what you can see here is a schematic that shows you the positions of the devices inside the tram. That depends on how many wagons there are, etc. So for the purpose of this presentation, this is a smaller one. And you see also the status there already. So we get an idea which components are being used, and we get an idea about the status of those components. Now let's talk a little bit about the notification. I mean, the monitoring is done for a reason, and the reason is to help the service staff. So let's talk a little bit about the notification. So they have, of course, their own workflow, and to make it short, we are using the trigger-based actions, and those actions tightly integrate into the notification process for the service staff to fix trams and subways if something is going wrong. And they're using event acknowledgements. So any of you are all of you know Zabbix, and you know the escalation procedure in Zabbix, you know the actions, and you know that you can use acknowledgements, and we use acknowledgements here as well. So they are really handled, they are really integrated in the workflow. This shows the problem view of subways, and you can see there are some acknowledgements already, and you see some of those actions are being done. We have the same for the problem view for trams, yeah, actually. So I mentioned that the idea was really to support the service staff and to give them visual feedback. So let's talk a little bit about how this project implements supporting the service. And what's being done is we made some minor modifications to the front-end code to give us some more options. And what I would like to show you is that the service staff can click on the map. You remember the map where you could see all of the subways, and you click on one specific subway, and inside that specific subway then you get this map, and then you can open a context menu depending on which device you click here in this map, and it shows you Einbauort anzeigen, and this translates into installation point. So show me the installation point, and if I click on that one, then it will open up an additional window showing the exact position, and that works for any device. So it works for the cameras, it works for the network video recorders, and it's really, really helpful for those people that need to fix those components. Another one I would like to show you is the position of the vehicle. That is this slide here. So it's saying in German Fahrzeugstandort, and that translates to vehicle location. And if I click on that one, what happens is I get a new map showing the real-time position of this particular device. And it's being done by, so we do collect the GPS coordinates in Zabbix, and we're using Zabbix API calls to get this information for this particular train out of Zabbix, and then we're using OpenStreetMap to show up this device. So very, very nice. Thank you. Yeah, and thank you to Mr. Sandro for having these great ideas also. Yeah, and coming to the end of this presentation, let's talk a little bit about challenges we faced. And really the hardest part is to predict connection losses. That's really the hardest part. If the tram moves, for example, it can be that there's a break, so it's at a position where there's no connectivity, etc. So it's not really predictable, or it's hard to predict. Let's put it this way. So really, this is an issue that we are still working on. So how to make sure we don't get any false positives. And of course, all of the triggers need to be connected to the availability of the trigger that controls whether the MRCU or the LTE router, depending whether it's a subway or a tram, whether they have connections. And for those technical guys of you, I think we are all technical, this is an example trigger definition on the bottom of the slide showing that the problem state is detected by using both the availability of the IP connectivity and the device, where the recovery connection is using just the device itself, and we're using this group functionality like mux, sum, etc. Yeah. So I think that was it. Yeah. Thank you very much for listening.
Yeah, thank you, Wolfgang.